So we have 5x minus 1. Always a good idea to draw it on the picture. Because if you're on a test, ooh, it's warm in here, is it not? Did it bump back up to 70? It keeps bumping up to 75. Always let me know if it's too cold or too warm. We can always adjust it a little bit. Hey, like I said, draw stuff on your test. We get points for just drawing stuff on it. So I have that 5x minus 1. We have VST. Remember, they give you the order of the angle that's being drawn. VST must be that one. VST is 17x minus 6. You know what I'm looking at right now? Either these two angles are equal and I can slap an equal sign between them, or they're going to tell me the entire measure of the big thing and I have to do something plus something equals the big thing. So in this case, they do tell us that RST, which is the whole thing, would be 147. So we have a little equation here that we have an angle plus an angle equals the big angle. So we have 5x minus 1 plus 17x minus 6 would equal 147. Let's quickly solve this. So I have 5x. Remember, if you're on the same side, you do whatever sign's in front of it. I did see people on quizzes and stuff like that, like they'd subtract 5x and then subtract 5x here. If it's on the same side, you use the exact sign that they're using. So it's 5x plus 17x. That's a good thing to remember. If it's on the same side, you do whatever sign's already there. You don't do that like subtract on both sides. So we have 5x plus 17x, which would equal 22x. And I also have this -1 and this -6. When you have a negative and another negative, it should be further negative. So we shouldn't have like -5. We should have -7. A negative and another negative will be further negative. So we have -7 equals 147. Now is when we start doing things to both sides. Because I simplified both sides. Now we have that -7. To get rid of a -7, we add 7. But when I do it to one side of the equal sign, we do it to the other side of the equal sign, giving me 22x equals 154. Our last step should be dividing by 22. Correct me if I'm wrong. Is that 7 then? Is that 7? I see some yeses. And here's the problem. 7 is not one of my answers. What did I do wrong? It doesn't say 7 over here, right? I didn't find VST. It says we're supposed to measure VST. So we locate VST. VST is at 17x minus 7. So we realistically have to now take that 7 and throw it into that 17x minus 7. And then you'll have your correct answer. I'll let you finish that. Yes? Yeah. But it's different? How is it different? What homework did we have? We had 2.1. Yeah. Number 3. Number 3 of 1, 8, 27, and 64. That would be a really hard one to come up with, like a plus something. It is doable. Let's go the wrong way about doing this one, okay? So, and it could be the way that you do it. So you might look at this and going, okay, this is what, plus 7? This will be plus 19. This one here would be plus 37. Okay, it doesn't necessarily seem like a pattern there yet. So what if we go another level? Well, another level would be plus 12. This one would be plus 18. So we can't get to the second level. It actually turns out it's the third level. If I did plus 6 to get here, it'd actually be plus 6 for here. But that's a hard thing to kind of get down to the third level. So what we'd have to recognize, and this one is just really just recognizing something. Remember how we had like that 1, 4, 9, 16, and we came up with that hard pattern for it, and it turned out we were just squaring numbers? It turns out that these are all perfect cubes. That 1 is 1 cubed. 8 is 2 cubed. 27 is 3 cubed. So then we have 4 cubed. Then we would have 5 cubed. Then we would have 6 cubed. Then we would have 7 cubed. And these really aren't ones that you should have. I mean, you could have memorized, awesome. But typically we don't have memorized, so I'll just fill in what we would have. So we'd have, well, 5 is easy, 125. But 6 cubed we could type in our calculator, which would be 216. Then we would have 343. Then we'd have 512. And then we'd have 729. So those were just perfect cubes. Those are one of the hard ones because you just have to be able to just see that they're cubes or they're squares, because you can't really do the nice pattern of adding or subtracting. Okay? All right, cool. What else we got? Yeah. Number 9? 5? Sorry. 5 we have, so these are just Roman numerals in order. So we have 1, 2, 3, 4, 5. So we might have had to look up how to do Roman numerals past 5, but realistically we'd have 5, and then we'd have 6, and then we'd have 7, and then we'd have 8, and then we would have 9. Oh, I forgot 9 for some reason. My brain is just dying. 8, yep. And then 9 is just the 1x, and then we have the x for 10. So that would have been Roman numerals, and you just had to look it up, how to do the Roman numerals. All right, what else we got? Yeah. 4? 4 are our prime numbers. So they're your prime numbers. So that could be a little bit of tricky stuff because you have to know what the prime numbers are. So if I have like 13, I know 14 doesn't work, 15 doesn't work, 17 would work. 18 wouldn't work because 2 goes into it, but then we have like 19. And we just have to kind of go up and find those numbers that nothing else goes into besides 1 in it. I can give us our full list real quick. So we should have had 119, 23, 29, and 31. So it's just our prime numbers. Once again, that one is really hard to do if you try to look at just adding, subtracting, multiplying, because it doesn't really work. Prime numbers are really weird in that way. In fact, there's a whole study of mathematics that's just prime numbers because they do these weird things. All right, what else we got? 11? Grayson, do you mind picking up your head? $11 says, for any integer x, x squared minus x will always result in an even number. So we're supposed to come up with true or false on that one. It turns out that this one is actually just true. It is actually a staple of a whole field of mathematics studies of how to come up with odd and even values. But what I would challenge you to do is pick any number and just see what happens when you square it and you subtract that same number from it. So we could try like 2 squared minus 2. Well, 2 squared minus 2 is 4 minus 2, which equals 2, so that works. If you try an odd number, say 3. 3 squared minus 3. Well, 3 squared is 9, minus 3 is 6. That will work. It'll work for 4, 5, 6, 7, 8, 9, 10. And usually if it's not one of those first ones, it's probably going to be a true statement. It works. And notice it says integer, so we could try 0. We could try like -1, -2. It will all work in there. This is actually, when you go to a field of mathematics, this is how you know something's even. Because you run it through this ringer and make sure that it works out here. So that's actually a true statement. Okay? What else we got? Yeah. 12. 12 is for any integers x and y. X plus y is the same thing as absolute value of x plus absolute value of y. Now, I'm just going to look at this and I'm going to assume it has to be false because that's not how absolute value. If these were the same thing, this is how we'd always write it. because it just makes sense to write it the easier way or the harder way. So now remember, if you want to break something, use negative numbers. That's always my advice, use negative numbers. So let's try x equals -2. Let's make y equal a -3. In fact, I think you could have just made one of them negative and you would have been fine. So let's check what absolute value of -2 plus -3 is. Well, -2 plus -3 is a -5. But we always do what's inside the absolute value first. So -2 minus 3 basically is a -5, but we still have those absolute value bars. And that equals, actually, I wanted to make one of those positive. I think I needed to make one of those positive. So let's make it a +3 instead of a -3. Okay, now I have -2 plus 3. Well, -2 plus 3, well, that's going to give me a +1. And the absolute value of 1 is just 1. So if I plug in the first one, -2 plus 3 is 1. Absolute value of 1 is 1. Well, if I run it through the other ringer says do the absolute value of x plus the absolute value of y. Absolute value of -2 is 2. Absolute value of 3 is 3, so I have 2 plus 3, which equals 5. Those are definitely not equal to each other, so that's a false statement. So our goal on that one was to make one negative and one positive. Yes? Number 16. 16, for any two integers a and b will be a plus b squared, does not, or equals our a squared plus our b squared. I just picked out the first two numbers I could think of, I think. I think you could try anything and it'll break it. I don't think there's very many numbers that'll work for, so I just said a equals 2 and b equals 3. So if we do that, we have 2 plus 3 squared. That has to equal 2 squared plus 3 squared. Well, 2 plus 3 is 5, and 5 squared is 25. 2 squared is 4, so I'm kind of speeding through this. This would be 4. 3 squared is 9. 9 plus 4 is 13. I don't think 25 equals 13, so this is false. It's just me plugging in 2 and 3. I don't think there's many numbers that actually work, so we just had to plug it in and just kind of make sure we're doing our math correctly. Yes? 10 says the difference between two negative numbers is always negative. So the difference between two negative numbers is always negative. So that means we're subtracting two negative numbers. So what I'm going to do is I'll set a equals to -1. I'll set b equal to a -3. Well, if I took the difference of this, we have -1 minus a -3. Remember, when you are subtracting a negative, it turns to a positive. So that's -1 plus 3, which would equal 2. That's a false statement because I took two negative numbers and it came out to being positive. Okay? Yeah. The difference between consecutive perfect squares is always odd. So the difference between consecutive perfect squares is odd. I think we could just say that one is actually true because I couldn't think of it on top of my head. So we'd have to know what our perfect squares are. Our perfect squares are 2 squared, which is 4, 3 squared, which is 9, 4 squared, which is 16, 5 squared, which is 25, 6 squared, which is 36. Well, if you take any one of those two, the difference between consecutive odd perfect squares is always odd. So if I did 9 minus 4, I get 5. If I did 16 minus 9, I get 7. If I did 25 minus 16, I get 9. 36 minus 25 is 11. No matter what order you do them in, you will always come up with an odd number if it's consecutive. So that means the next one in the order. Okay? All right, that's all we really have time for. I think we did most of them, but we need to kick off today's lesson. And today's lessons are on statements, conditional statements, and biconditional statements. This is a biggie. This is a biggie. We're going to get to if-then statements, which are a biggie for any quiz or test that we have. So the first thing we have is I can give you a statement. We talked about statements before. A statement doesn't have to be true. In fact, a statement is a sentence that has just two options. Either it's true or it's false. There's no ambiguity. There's no it's kind of true. So if I give you a statement that everyone in this classroom is under 20 years of age, it's either true or it's false. Well, in this case, it's false because I'm over 20 years of age. It's not, well, if Mr. Pabian's out of the room, then it would be. It is either true or it's false. There's no kind of true and kind of false. This is called our truth statement or our truth value. Truth statement or truth value. I'm just going to put value because it's a shorter word. When we talk about these letters, and more predominantly when we get to our if-then statements, we use letters to talk about them. So we typically represent statements by either using the letter P or the letter Q. It allows us to write things very, very quickly, like P is this, Q is this, instead of having to rewrite the whole statement every single time. So recognize P's and Q's are going to be important to this thing. So, example, supplementary angles have a sum of 180 degrees. Is that true? Or is that false? Do supplementary angles equal 180 degrees? I see a couple people shaking their head. We got to know this, guys. It's true. That's the definition of supplementary. Supplementary means two angles that add together to give us 180 degrees. So that is a true statement. Now, so we have a statement, and then we can negate that statement. Negation is basically the opposite of the statement we're trying to give. That is called a negation. A negation of a statement has the opposite truth value. It will always have the opposite truth value. We use this little tilde to be our negation. So what we do is we use this symbol, this. I use P, and that's read as not P. Whatever I said for my statement, I want to say the opposite of it. That is our negation. That is our not P. So if my P was supplementary angles have a sum of 180, we're going to throw a not in there. We're going to throw a not, and we'll put, okay, negating P is supplementary angles do not have a sum of 180. Well, that's got to be false. Because I already said that supplementary angles have a sum of 180. So if you tell me they don't have a sum of 180, that's going to be our false of that statement. All right, so real quick, over here, just for a quick recap. Statement. Statement is either true or false. If we have just one statement, we use P in it. True, false, we let P represent it. For a negation, you think opposite. And you write it like this, not P. Remember, that stands for not. Okay, but we already covered statements. We already said whether these are true, false. We have statements. You say something, either it's true or it's false. Now we're going to get to what is really the core of this lesson, and that is conditional statements. So we have statements, and then we have what are called conditional statements. So I can make a statement, like I said, a regular statement is everyone in this classroom is under 20 years of age. A conditional statement are kind of a combination of two statements. It is, if this happens, then this happens. So let's say you have baseball practice after school. We can say something like, if it rains, then I won't have practice. So you having practice is dependent on whether it rains or not. That is why it's conditional. It's based upon if that first thing happens. So a conditional statement. A conditional statement is a statement that can be written in the form if, then. If this happens, then this happens. If this happens, then this happens. So the symbolic form of this is we're going to do P, we're going to draw an arrow, and we're going to draw Q. This statement right here is read, if P, then Q. In fact, this arrow in mathematics always means then. In mathematics, if I want to say then, I just use an arrow. So your arrows always used when you want to talk about then. So an if-then statement is we put P, then symbol Q. And that is read if P, then Q. Or you can read it as P implies Q. We typically won't use this one. We'll stick with the if-then statement. It's tough enough with just the if-then. All right, an if-then statement's made up of two things. I have kind of two statements. If it rains out, then I won't have practice. We have two things happening there. We have the rain and we have the practice. That's why we break it into two different things. We call them the hypothesis and the conclusion. So your hypothesis is going to come first. You have a hypothesis. My hypothesis is based upon the rain. So your hypothesis is that phrase that immediately follows your if statement. So in my statement, my hypothesis is it rains after school. My conclusion is I don't have practice. So the conclusion is the phrase that immediately follows the then statement. But I will point out your hypothesis is represented by the letter P. Your conclusion is represented by Q. So whenever you hear me talk about P's or Q's, I'm talking about your hypothesis and your conclusion. Your P's and Q's are your hypotheses and your conclusions. Make sure you keep those letters straight, because sometimes I'll just put P and Q and you have to know what I'm talking about. So P means your hypothesis, Q means your conclusion. Here's the good thing. If you're paying attention to what I'm saying and you practice this, if I ask for a hypothesis and conclusion, it's going to be like the easiest thing that shows up on a test and quiz, and will always show up on tests and quizzes. So in the next thing, it says identify your hypothesis and your conclusion. The only thing you can get wrong, well, first of all, you can be nodding off and not paying attention. The second thing we could get wrong is we put an extra word in it. When I ask for the hypothesis, I want the statement right after the if statement. I don't want if. I want what's after the if. You live in Nashville is your P, is your hypothesis. So if I ask for your hypothesis, I don't want the word if. I want you live in Nashville. If I want my conclusion, so notice how I boxed in my hypothesis. It's a good idea to do this and then do something else for your conclusion. So what I'll do is maybe circle or underline, you live in Tennessee. That's way if I make a mistake writing it, it'll be fine, because I can see, Mr. Pabian will know, hey, I boxed in part of it, I underlined the other thing. Maybe you confused the two, but at least I knew one was the hypothesis and the conclusion. Our conclusion is you live in Tennessee. Do the next one. That was perfect. It is just the sum of the measurements of two angles is 90 degrees. That is our hypothesis. they are complementary angles. So maybe we'd underline that. They are complementary angles. I'm not going to rewrite it, but we have that as our conclusion. Perfect. And we didn't say then. That's the perfect thing. We want to say these. Is that hard? No. Are people going to get it wrong on the quiz and test? Yeah, because you're not going to look back at your notes or anything. Get this stuff right. Even the stuff we're about to do where we switch some stuff, it still just takes a little bit of practice, and it's stuff we need to master because we will have proofs in this chapter, and we want to get all this stuff done perfectly, so if we make mistakes on our proofs, we're okay. All right, the next part is really just English semantics. We need to write each statement in the form if or then. I need to rewrite these statements as if-then statements. So we start off with an obtuse angle has a measure greater than 90 degrees. I want to be if this, then that. It is your job to pick out the two facts that are being talked about here. So what I'm looking here is we have an obtuse angle. That is the first fact they talk about. We need an obtuse angle. The second fact that they have here is measure greater than 90 degrees. And in fact, what we're doing is we're locating what the hypothesis is going to be and what the conclusion is going to be. So the first fact we have is we need an obtuse angle. The second fact describes what an obtuse angle is. So I have two things. Now, the only hard part is we have to put it in basic English because I can't say if obtuse angle then measure greater than 90. I can't sound like a caveman when I'm doing this stuff. So what we're going to put is something like if an angle is obtuse or if you have an obtuse angle. Something of that nature that we have an obtuse angle. So I'm going to go with if an angle is obtuse. Instead of saying then measure greater than 90, then you're going to say then the measure is greater than 90. We're just trying to find a good way in English to kind of say that. So if an angle is obtuse, then the measure is greater than 90, or then its measure is greater than 90, or then the angle's measure is greater than 90. However you want to put it, I'm not looking for perfection here. Even if it's kind of clunky English, I'm okay with it. We just need to realize what the if portion is and what the then portion is. So if an angle is obtuse, then I'll just put its measure is greater than 90. Then 90 degrees. All right. Our job is just locate the two facts that are being said and try our best to put an English spin on it so it doesn't sound like you're a caveman. Our next one, it says all numbers divisible by 4 are also divisible by 2. I'd like you to give that one a shot. What I want is just a little bit of help. You don't have to give me my whole thing. What's one of the statements I need to make? So what I mean by that is I had obtuse angle was one thing. The other thing was measure is greater than 90 degrees. What's one thing I need to conclude in my if-then statement? Yeah, Caroline. Numbers divisible by 4. You got my other one? What do you got? Also divisible by 2. So they're saying all numbers are divisible by 4 need to be divisible by 2. So my if-then statement should be like, if I have a number that is divisible by 4, then it's also divisible by 2. So if, and I saw someone had like all, a couple people had all on it, that's okay. But a more precise one would be if a number is divisible by 4. If a number is divisible by 4, then it's divisible by 2. The big old deuce. Sometimes they be trickier than they look, honestly. I can make it seem as simple as in the world because I just say that's a statement, I need an if then, but sometimes they get really confusing. Sometimes it feels like I can't even pick out the two statements they want. All right, so these could be more confusing than they look. Hopefully we got the hypothesis and conclusion down. Get that one down. All right, are we good with hypothesis and conclusion? Can we locate a hypothesis and conclusion? Good, because the thing that takes up a big chunk of quizzes and tests is this next thing. They are called inverses, converses, and contrapositives. They are based upon you having an if-then statement. So let's go up here and say we have a conditional. We have a conditional. If it's a conditional, we have P first, followed by Q. You have your hypothesis, followed by your conclusion. We have our hypothesis, followed by our conclusion. If it rains out, then I don't have practice. If it rains out, I don't have practice. Rains out and practice, my hypothesis and my conclusion. The first thing we're going to talk about is an inverse. An inverse is made by keeping your statement in the same order, but you negate both statements. So it's formed by negating the hypothesis and the conclusion. You negate your hypothesis and you negate your conclusion. How it looks symbology-wise is it's not P, then not Q. So in my example, my conditional was, if it rains out, then I don't have practice. If I negate both those, I'd say, if it doesn't rain out, then I have practice. I do the opposite of both statements. So you negate both things. Basically, you're putting a not in front of both things. Not the hypothesis, not the conclusion. If not, then not. Even if you have double negatives, not will still work. I will not have practice. That means I have practice. Just in case you're falling into that trap of just putting nots on everything. All right, so that is inverse. Converse is formed by switching the hypothesis and conclusion. It is going to be formed by switching the hypothesis and conclusion. So instead of P then Q, we're going to have Q then P. If I don't have practice, then it rained. If I don't have practice, then it rained. Contrapositive. Is that not the fanciest word of all three of them? I think a fancy word has a lot of things happening to it. That's what I think. That's how I always remember what a contrapositive is. Contrapositive, that's that fancy word. You are going to negate and switch. So you'll do what inverse does, and you'll do what our converse does. So we are going to negate, formed by negating, and switching the hypothesis and the conclusion. So it'll be not Q, then not P. So we're supposed to write the inverse, converse, contrapositive of the following conditional statements and then determine the truth value. That is it true or false? So the first thing we have is, if it is Saturday and we don't have detention, I'll put that on there too, then there is no school. Is that a true statement? Yeah. You have to go to the bathroom? Yeah. You're just going to miss some stuff. All right. If it is Saturday, then there is no school. Does that sound true? Yes. It is Saturday. You have no school. That's a true statement. So we're going to start with true. Now, inverse is where you flip both your hands. That means you put not statements. Keep it in the same order. So maybe we should go ahead and locate our hypothesis and conclusion real quick. So my hypothesis is it's Saturday. That's my P. There is no school is my Q. So our inverse is just throwing knots in front of stuff. It is flipping your hands. It's just throwing knots. If it is not Saturday, then there is school, because we're negating it, right? So the opposite is no school, then there is school. So Our statement is, if it is not Saturday, then there is not no school. Doesn't really make sense. I would understand what you meant, but we're negating it. We're doing the opposite. So if it is not Saturday, then there is school. So I guess the negation is the is. Oh, school should have a C in it, doesn't it, usually? All right, we got to be careful about these truth statements. If it is not Saturday, then there is school. If it's not Saturday, then there is school. Is that 100% true? You're shaking your head. What would apply to this that would break it? Sunday. What was that? Or a holiday. Or it could be summer, which is a holiday, right? So we could put, hey, it's a holiday. Or we could put Sunday. Whatever you want on there, whatever your first instinct was, go for it. These are your notes, whatever made sense to you. In my notes, I just have Sunday, so I'm going to use Sunday. But I love the holiday thing. I love anything that just says, hey, it's not Saturday, but I don't have school. Oh, truth value. I wanted a truth value, but that would be our, hang on, we should probably put false. It doesn't really ask for a counterexample, but I'm going to go ahead and put Sunday down. But our key thing is false. All right, converse. Remember that's where we just switch our hands? Did we flip our hands for converse? No, we just go straight across. So that means you take your hypothesis and you swap it with your conclusion. So our conclusion will now come first. If there is no school, then it is Saturday. So we go ahead and flip. So we put there is no school. Then it is Saturday. If there is no school, does it have to be Saturday? No. What are some examples of a day you don't have school and it's not Saturday? Sunday or holidays. We could do the same thing, right? Almost the same counterexample. So we could go false. We could use Sunday again. If they ask for it doesn't ask for a counterexample, so this isn't, I wouldn't grade you on it, but I might ask for a counterexample. So we have false again, and we have Sunday. Isn't it weird that it's the exact same counterexample, though? That might be important. All right, contrapositive. That's that fancy word. You do everything to it. You negate everything, so we need nots, and we need to flip things. So it's basically we can go from the converse straight to the contrapositive. We can go, if there is school, then it isn't Saturday. If there is school, then it is not Saturday. If there is school, then it's not Saturday. Is that a true statement? So you have school. Right? So it says, if there is school, so you're in school. Then it says, then it is not Saturday. So you're in school. Is it not Saturday? So we can use school on Monday. Is that Saturday? Tuesday? Wednesday? Thursday? Friday? No, it's probably the hardest one to keep track of. This one is going to be a true statement. Pay attention to this next thing. It makes your life easier. My next statement, I'm not even going to write it down. You can write it down or you don't have to write it down. A really easy way to come up with your true-false statements is your conditional and your contrapositive say the exact same thing. Their truth values will be the exact same. So whatever your conditional is, if your conditional is true, your contrapositive is also true. Your inverse and converse also say the exact same thing, just in a slightly different way. So they will have the exact same truth value as well. So really, you just have to check your conditional and your inverse, and you have the rest of them. So once again, for people that didn't write this down, but it is important, it might be nice, your conditional and your contrapositive will have the same truth value, and your two middle ones, your inverse and converse, will also have the same truth value. It makes your life really easy because sometimes the contrapositive is really hard to figure out if it's true or false. You can just go back to your conditional and say, oh, my conditional is true, so that needs to be true as well. It's a nice shortcut. I'd highly suggest knowing that information. All right, if you could, I would like you to do number 6. If you're already done, or when you get done, I would like you to share your information with your group members. I would like everyone in the group to have the same answer or know why you have a different answer. All right, let's give that a shot. All right, guys, let's take a peek up here, just so we have enough time. I want to get through biconditional, get through that. So we should have realized that inverse is where we drop our hands, where we put knots in front of everything. So I just made sure I kept everything in order. So we kept our hypothesis and conclusion. Maybe we should start off real quick. So here's my hypothesis. Here's my conclusion. I should probably see if that one's true or false first. So if the temperature is 25 degrees, do we agree then it has to be below freezing? So it's 25 out. Does it have to be below freezing? Ooh. If it's 25 degrees outside, does it have to be below freezing? Yeah, thank you. If it's 25, it's the definition of below freezing. If it's 25, it has to be freezing out. That's per the definition. So this is true, which, if you paid attention to what I said before, we could have just came down here and put true right here. If I'm on a quiz or a test, I could just say, oh, the conditional is true, so my contrapositive has to be true. And at least I get a point. I'm like, okay, this one was true, so that one has to be true. They have to match. All right, then my inverse is just throwing the word not in. If the temperature is not 25, then it is not below freezing. Now, kind of was ambiguous about this when people asked for help, because if the temperature is not 25, so it could be 26, right? If this was 26, it'd make the statement true. But remember, you just need one example where it's false and the whole statement is false. Can anyone think of a temperature that is not 25 that is not below freezing? Or that is above freezing or below freezing? I said that wrong. Yeah, I will say that again. So a counterexample will be a temperature that's not 25 but proves the next part false. So is there something that's not 25 that is actually below freezing? Yeah, I put 20 degrees. That would be that would be our counterexample. That 20 degrees makes the first part true, but it makes the second part false. That is our counterexample. It makes the first part true, the second part false. Are we clear on that?
What is like defined as below freezing?
Below 32. And that if you're on a quiz or a test and you're not sure of something, just raise your hand and ask me what's below freezing, so we can all be clear on that. Because I don't want like little semantics getting in the way of us understanding these true-false statements. All right. Hey guys, if this one's false, what do I know about the converse? It's also false, and we can actually use the same counterexample. If you paid attention, put in your notes, that'll make it easy. Converse is you just switch your hypothesis and conclusion. So if it is below freezing, then it is not. Then it is 25 degrees. Your contrapositive is not and flip. So we should have if it is not below freezing, then it is not 25 degrees. I am telling you, if you haven't put in the notes that your conditional and this value are the matchup and these two match up, you're doing yourself a disservice. Because you should be able to just get these first two and know the last two. All right, the last thing we're going to talk about is something called biconditional. Do you notice how both of these had examples where it was like true, false, false, true? To be biconditional, all statements have to be true. But here's the cool thing about that. You don't need to prove all 4 of them are true, because remember how I said your conditional and your contrapositive have the same truth value? And your converse and your inverse have the same truth value? So what we do to prove an if and only if statement is true, we actually just check to make sure the converse and the conditional, because those are the easiest because you're not throwing knots in them. But we'll get to that in a second. So the definition of a biconditional statement, let's do the mathematical thing, but basically everything's true. So we're going to go with the conjunction of the conditional and its I don't like it. It is the book definition, but we'll go through it. It is the conjunction of the conditional and its converse. The conjunction, I'm already going wrong. I'm going rogue. It is the conjunction of the conditional and its converse. Realistically, I'm not going to memorize that definition. I didn't memorize that definition. What that means is your conditional and converse are both true. That's all that means. Your conditional and your converse must be true. Your conditional and your converse must be true. So if I ask for a definition of this, I would actually just prefer your conditional and your converse are true. And that's what it says here. The symbolic form is if P then Q, and this is the and symbol in math, and Q then P, those are all going to be true. So we rewrite this as P and we put a double arrow on it. We put a double arrow on it rather than just one direction, because your conditional and your converse are both true. So the way we read that double arrow is if and only if. So it's read as P, if, and only if Q. So, truth value. Biconditional statements are true when both the conditional and converse are true. That's all you check. You check for a biconditional statement that your conditional and your converse are both true, because that means everything's true. So my first example says 2 angles are supplementary if and only if the sum of their measures is 180. In order for this to be the true statement, you have to be able to write that in 2 different directions. Now note, we do have 2 statements. We have 2 angles are supplementary, and we have the sum of their measures is 180. So the conditional is going to be one direction, or converse is going to be the other way. So our conditional is if 2 angles are supplementary, I'm going to shortcut this and just put sup, then the sum of their measures is 180. So if 2 angles are supplementary, then the sum of their measures is 180. If the angles are supplementary, then the sum of their measures is 180. Is that true or false? If you have supplementary angles, do they add to 180? Yeah, that's the definition of supplementary. The definition of supplementary are two angles that add to 180. So that's true. The converse is just flip your two statements. So instead of if the two angles are supplementary, we're going to start with if the sum of two angles is 180. Is 180 degrees, then they are supplementary. Then they are sup. To ruin the suspense, that is also going to be true, which means your biconditional statement is also true. So your biconditional statement must work both directions in order for me to say it's completely true. So if the sum of the two angles is 180, then they are sup. That's true, which makes both values true, which makes our biconditional also true. I'm just going to take a picture of the last one. We're running a little bit out of time. If you missed that one, I could put it back up in a second. I do want to just show the next one. Because the next one would have a conditional that says if x squared equals 25, then x equals 5. I said that's false because x could have been negative 5. Because negative 5 squared is 25. In fact, I could have stopped here because if one of them is false, then it has to be false. But the converse is actually true. If x equals 5, then x squared equals 25, which is true. But it doesn't matter because it was written as a biconditional as false because one of them was false. In this case, it was conditional. Hey guys, the big thing about